Please welcome Adrien and Rémi as they talk about Unity's new HDRP water system, which is fully integrated into HDRP. Take it away.
Thank you.
Parti.
So, hello, my name is Adrien. I'm a graphics engineer, and I'm here today with Rémi,
Hi.
a software engineer in quality. We're both working at Unity on HDRP, and today we're going to present the new HDRP water system we've been working on for a bit more than a year, and that's going to be available in 2023 tech stream. So we'll start the presentation by explaining the core concepts behind the water system, as well as some of the design choices. Then most of the presentation will focus on building a scene, showcasing most of the features available to you. Then we'll have a bit of time talking about the performances. Then we'll show the assets that we have built for the users that are already available online. And we'll finish by a Q&A session. So before we really dive in, let's talk a bit about how the system works. It's been designed to render multiple large bodies of water from ocean to rivers, to pools, sorry. So it's definitely not meant to do like puddles or a cup of tea, but you can try. And by default, so we offer 3 different presets with different parameters that are suited to your needs, at least that's what we expect. And we have put a lot of effort in performance as well as customization. You can do that through all the parameters we have, or custom shadow graph, or there are really a lot of ways to do that. So now we'll quickly see how the simulation works. So the waves are procedurally generated using an FFT simulation, which roughly works by summing a lot of simple waves that adds up together to make complex agitations. And by controlling the range of frequencies, you can control the overall agitation of your water. So we have divided the simulation in 3 different bands that you can see there, which are made to a different level of detail. So for example, pools only have the highest frequency band that we call ripples. Then rivers additionally have agitation, and the ocean has the full range to render all the different possibilities that you can see. And for technical details, the simulation is done on a square patch and is then tiled into infinity, so you can have infinite waters. And the simulation is completely deterministic, so that means that you can use it to make online games, on multiplayer games. You can do physics simulation, or you can also render movies, for example, short movies. And some more additional details. It uses vertex displacement, and so with procedural geometry, it's very similar to terrain rendering. So it's instantiating quads infinitely to have adapted density where the camera is. And on top of that, it can use GPU tessellation, which can subdivide the triangles even more using special shaders. So that way you can have very high vertex density and a nice rendering quality. And so now we're gonna switch to the other part of the presentation, which will build the scene, and I'm gonna hand it over to Rémi.
Thank you. So now that you understand roughly how the system works, we're going to try to build together a scene from scratch, showcasing a river going into an icy environment. This scene will cover most of the available feature in the GRP water system, and the final scene that we are building together will be available as a sample for every user afterwards. So just so you know what you're getting into, what we'll start with is this, and then we're trying to build this. So basically making a river flow into the environment, a waterfall, making things float on it, foam, and etc., etc. So let's start quickly by adding water, by enabling water rendering into the volume, and then using the game object menu to add a river. As simple as that. Now that we have a river, what we want is adjust a little bit the simulation setting. So let's first change the repetition size to adjust a little bit to avoid tiling given the scale of the environment. We can also change the agitation by changing the wind speed, as you see there. Next, we're going to dive onto the appearance tab and change the scattering color, which is roughly the base color of the water, and how lighting will respond to it. We can also change the absorption distance, which is roughly how transparent the water is and how light will penetrate into it. And we can also change the refraction color, which is an artistic override, how to tint basically what goes through refraction. And also we can also change the refraction maximum distance, which basically will distort the water depending on how deep it is. Now that we have a good looking river, it's missing a key component of what is a river. It's current. So we're gonna simply add a current map, which is a pre-authored map that has been authored through an external software. This map is a bit similar to a flow map. And one limitation that we have is that the speed will be uniform all along the river. One cool thing is this debug mode to be able to make sure that the current map that we've made is properly aligned and that the current goes in the expected direction when you make it.
Ça va maintenant?
And now Adrien will talk a little bit about the waterfall and how to make all this stuff.
Yeah, so right now our river is flat and our geometry includes the drop here. So we're gonna create a waterfall and start by putting the river at its lowest point, and then we're gonna raise the beginning of the river. So to do that, we have a feature called deformation that we have to enable on the water surface. It's local to an area, so there is a debug mode so that you can set the size and offset and everything. So there it's set up correctly. And now we're gonna create a water deformer. So this works a bit like a height map that you can project on the water and raise locally up or down the surface. And we're gonna create there a big water deformer at the beginning to raise the most of the river, and then use a special texture that we've made to precisely push the geometry over push the surface of the water over the geometry, so that we get a nice waterfall. And then we can add a third deformer to add ripples at the bottom, so that we get a nice effect. Then, to better feel the flow of the waterfall, we're gonna want to add a decal. So basic HDRP decals work on water. We just need to make them affect transparent. And we use a custom render texture with a flowing animation to get that nice feeling. Then we can use decal layers to have the decal only affect the water and not the geometry underneath. And basically that's it. So now this water is more grounded. Just a note, you can only inject foam through decals, you cannot inject color. So if you want to make like a lily, I don't know, you can't. Yeah, and now we're gonna show the custom material. So it's a shadow graph target that you can use, the water target. And basically you can completely customize the appearance of your water. So we're just going to use it to inject custom foam here. Not going to go into the details because it's a bit complicated, but what we're doing here is reading the depth buffer to add foam near the edges of the water where there is geometry. And additionally, we're going to add a custom texture, like a scrolling texture, to add that foam at the bottom of the waterfall. So this is pretty easy to do thanks to shader graph. And yeah. Now I'm gonna give it back to Rémi.
Thank you. Now let's talk about caustics. Caustics should already be enabled by default when using a river. So usually you want to have the finest details, so the ripple band, as we said earlier. There's a bunch of parameters that you can change here, like the virtual distance, which roughly changes the blurriness or the sharpness of the caustics. You can change the tiling of the caustic, the intensity, and also the blend distance from the water surface to avoid having caustics right on the edge of the surface. To dampen the caustics into the shadows, we have an option called directional shadow. Technically, this has a slight performance cost, but makes it closer to what happened in real life because there's no caustics in the shadow usually. One cool thing to do with caustics as well is to be able to sample the caustics buffer outside the water. So as you can see now with the decal projector, we can project a reflection of the caustics on the wall. One limitation is that caustics are not affected by current map. This is why it flows in the wrong direction. But if you change the orientation here, you can still, as a workaround, make the caustics flow in the proper direction. So now it's better this way. Now that we have a good looking river that's flowing, we're going to try to make things float on it. So we're going to enable script interaction, which basically replicate the simulation done on the GPU, but on the CPU. This has a slight performance cost because it's running the simulation twice, basically. But those costs can be reduced by running the simulation at half resolution or just removing the ripples from the simulation. And now we can query the height and the current at a specific position and use that to make object floats and adjust position over time. One thing that we didn't talk about yet is the foam generators. You can add them to objects, and basically this will inject dynamic foam that would fade over time, creating a nice trail, as you can see on the debug mode here. So it really helps make the object more grounded in the river. And since we already add a current map, the object will follow the flow of the current map here. So there's nothing else to do to be able to have like gameplay interaction with it. And now I'll let Adrien talk about how to turn this into an ocean.
Yeah, so basically we've only created a river here, but now we want to make it infinite. And so we're going to switch the surface tape to ocean, which, as we talked at the beginning, we'd add a bond to the simulation. So we're going to want to adjust our wind speed and our agitation to make it realistic in the infinite ocean. But unfortunately, that also has an impact on our river. So since we want smaller waves there, we can use a water mask to dimmer the agitation locally so that we keep the same look as before. And there is also a debug mode so that you can see how much each frequency is affected and everything. Then we're going to just quickly adjust the caustics because now that we have one more bond, we want to have the ripples only contribute to the caustics. So only the smallest waves, because that looks nicer. And on top of that, HDRP supports foam. So foam generated based on the simulation. So we're going to enable it. We can tweak how much wind generates foam so that we have more or less amount. And the same as with the agitation, we want to mask it locally inside the river because we don't want foam in the river. And now, to finish, we're going to add some pre-made shore wave deformers near the delta to have some nice waves there that also generate foam automatically. So it looks nicer. And yeah.
One important thing that we didn't talk about yet is water exclusion. So we're going to try and demonstrate that very easily by adding a boat. And you can quickly see the problem here that there's water in the boat now. So we can just create a really simple mesh that's roughly the size of the boat and convert it into a water excluder. And that way, water won't render into this mesh. And since this mesh is a child of the boat itself, when you move the boat, water is still not rendering inside the boat, so it's very useful. Here, we could have used the boat mesh and duplicate it to do the same, but that could introduce like Z-fighting artifact, so it's better to use a very simple mesh like we did. And last but not least, now that we saw the tip of the iceberg, we're gonna try and dive and saw the immerse part. So we're gonna start by enabling underwater into our water surface. And when you enable that, you enable HDRP to still render acoustics, absorption, and refraction when it is underwater. When it's underwater, when the camera is at the limit below and above the water surface, HDRP under what we call a water line. So that's the line we saw here. And this water line can be easily customized. It's customizable, basically, via a shader graph and by using a custom pass. So we won't dive into the details here. But basically what we do here is blurring the line to make it more real and distorting a little bit of the UV above, since water usually go a little bit on the water lens of the camera to create this effect that we call a meniscus. So that's wrap it up the scene that we tried to build the cover. Now that we've built the scene, I'm sure you're wondering how smoothly this runs, so I'll hand it over to Adrien and talk about performances.
Yeah. So we have profiled the scene that we just showed you on latest consoles, and actually on various consoles. And all of the rendering times on GPU summed up takes a bit more than 4 milliseconds on Xbox Series X at 4K resolution. So it's pretty nice. On low previous generation consoles, sorry, it's a PS4 at 1080p, we get a bit less than 8 milliseconds. So most of the cost here is coming from the vertex density and the G-buffer pass, because the system is using deferred lighting with clustered shading to get lower frame time. And so we have a G-buffer pass where we render our geometry, and depending on the amount of vertices that you have, it's going to take more or less time. So we have a lot of settings there that you can use to customize that and adapt it depending on your target hardware. So there are also other settings, but now we're going to look a bit more in details at the number. So for the CPU, you can see that the cost is overall fairly low. It's less than 1 millisecond, and most of it is coming from the script interactions feature that we have enabled, which basically replicates the simulation of the waves on the CPU to sample it from script. So this is, you can disable or enable it if you don't need it. And just so you know, it's most of the time on the CPU. The GPU is actually more interesting because that's where most of the stuff happens. This is the capture that we've done on Xbox, so it's 4 milliseconds. At the beginning, you can see the updates that are done per water surface. So here we have only one. But there is the foam, the caustics, the deformation, the simulation, which are very fast. Then, as I mentioned, there is the G-buffer pass, which renders the geometry that we try to split with the GPU tessellation and only the vertex and pixel shaders. So the tessellation can be disabled on the surface if you need that more performances, just so you know that will reduce the vertex density, so you will get less visual quality. But you have a lot of control there that I'm going to talk a bit more after. And finally, there is the lighting pass. So this is a full screen pass that depends on the amount of water pixels that are on screen. But yeah, it's using classification so that, like, if you have an area light, it's going to be a bit more expensive, but we've made it so that it's the fastest possible. So performance of the G-buffer pass. So if you're using procedural geometry, we have a setting called triangle size, which basically lets you tweak the average size of a triangle on screen. And when using GPU tessellation per water surface, you can control the amount of tessellation as well as the fading start and end to adjust the amount of triangles when the camera gets close to the water. And yeah, there are also plenty of other parameters in the HDRP asset that you can change, but we're not going to cover everything.
Now let's talk a little bit about the samples. The scene we built together before is not the only freebie you get as a user. Basically, since water is a complex system, we really wanted to give user a head start on how to build a different setup. So in addition to the scene we built together, there is 3 different scenes that are accessible through the package manager in HDRP package. There is a pool scene which focuses on setting up multiple water surfaces with custom meshes. There is the island scenes, which focuses on how to make shore waves, how to make foam literally outside the water surface with decals and a flipbook and animation, all that stuff. It's also using burst to make the seagulls, that looks like dots here, but I'm sure they're seagulls, floats on the water at a reduced cost. And there is also the custom pass that we saw earlier to blur the waterline on a completely separate scene to isolate the effect, make it easier to inspect, basically. So all of these things will give you a head start, and there is plenty of script, materials, and graph you can use to educate yourself or just use in a project that you want to start, basically. And in addition to that, we also will offer a bigger project that will look like more a real video game setting, which with huge meshes, large texture, regular post-process stack, etc., etc. So for example, on this scene, what we call the island, you'd be able to walk with a third-person controller on the island, make it interact with water, see how the VFX graph integrate also with water. So there's plenty of things that you can explore in this scene. And there is also 2 more scenes in this real big project. There is this river scene that basically is a better looking scene that we've built together, which uses extensively decals on the water to make it feel better, the flow of the river, and add foam and all that stuff that we already did earlier. And there is a very simple pool scene that uses only one bend, very small perturbation, and a nice waterfall at the end. So those scenes will be available via GitHub repository in a few weeks. So we'll make a post on the forum when it's available, but it's a matter of weeks, so it's going to be really short. And as we said earlier, all the scenes, the simple lightweight scene that we saw, are already available via the package manager in the HDRP. They are very lightweight scenes. As you can see, they are roughly 10 megabytes. So you can import them very easily and use it to iterate on your project or just to educate yourself. So that wraps up our presentation. We want to thank all the people that worked on the water system from the past year that can't be here today, sadly. And we want to thank you for listening. And we still have a few minutes, like 6 or 7 minutes, to take questions if you'd like. So don't hesitate to take questions. And if you're too shy for asking questions here, you can always talk to us afterwards. We'll be around. So thank you very much for attending.